All right, welcome back, everybody. I don't remember when the last time we actually streamed was, but um, I think it has been a while that we've streamed. It's been a while since we actually streamed like cluster design work, and in that time, we've made some progress on implementing some of these APIs. I think today our goal is to try to focus on the shard manager piece of the puzzle. And maybe we can talk a little bit about like what the shard manager is actually responsible for in the cluster. And then we can sort of dive into the implementation that I'm working on. So the shard manager is responsible for managing the assignments of shards to pods. So if we maybe like look at the interface of the shard manager like data type, we can probably get a good idea of the things that it's capable of doing. Um, so one of the things that the shard manager is capable of reporting on is the assignments uh, that are currently present in the cluster. So get assignments on the shard manager returns a hash map of shard identifiers to an option of pod address, because there may be shards in the cluster identified by a shard ID that haven't yet been assigned to a pod. So in that case, you'd have a shard ID mapped to option.none. Otherwise, you have the shard ID mapped to the option of the pod address, a sum of the pod address. So we can get the shard assignments of the cluster. We can get sharding events, but these aren't really that important at the moment. We can register new pods with the cluster, as well as unregister previously existing pods from the cluster. And unregistering pods also unassigns all the shards from that pod, and then the cluster would rebalance those shards to other pods within the cluster. We can also trigger a rebalance manually with the shard manager. And I should probably add to this little JS doc here the same JS doc that I have sitting in the actual implementation. Rebalance. Here. So rebalancing will trigger reassignment of shards across pods in the cluster. It'll try to balance shards across the registered pods, and if we have this like immediate parameter, and if the immediate parameter is true, shards will attempt to be rebalanced immediately. I think it's probably easier to understand what that parameter means in the context of when immediate is false. So if immediate is false, shards will be rebalanced according to the rebalance rate. So we don't want, in most cases, we don't want all shards to be rebalanced like instantaneously across the cluster. We want it to happen like kind of like over a particular period of time. And so the rebalance rate allows us to control how fast shards are actually rebalanced across the cluster. But there are cases where we do want to do it immediately. For example, when we actually unregister a pod, which is right here, this unregister method, you can see that one of the things that we do here is, let me just
Because basically, in that case, we will have shards that are unassigned.
right.
So we want to
So
immediately reassign those shards.
precisely, yeah. So in this case, we'd be rebalancing like instantaneously, trying to get those shards as assigned to new pods as quickly as possible. Um, what else? Let's go back to the interface. And then the other
By the way,
piece,
just a little comment that I'm looking at the code on the right side. I think we have some fork daemon in the wild. Those fibers will not be monitored. Will not be like if it
yeah,
shuts
there.
down or stuff like. Probably we should at some point track the fibers into a proper life cycle thing.
Yeah, so there are quite a few instances where we fork daemon fibers inside the shard manager, and I haven't replaced them with like a scoped fiber yet. But one of the next passes of improvements I want to do is like proper life cycle tracking of all the fibers we're spinning up. Because in Shardcake they spin up a lot of daemon fibers, but I think it might be better to track those fibers like life cycles within a scope, or something like that.
Yeah, either on a scope or like one of the data types that team created, like fiber map, fiber set, stuff like that.
Exactly. So I think that's kind of like a next iteration for this current iteration. My focus is like basically making sure that rebalancing works and that it's relatively performant when it occurs. It's not a operation that needs to be like extremely performant, but we want it to be as quick as we can. So, um, but anyways, the last piece of the shard manager here is kind of the interface that you have in the shard manager to the pod health API. So, shard manager can notify the cluster. Sorry, Mattia is commenting on the definitely diverging from shard cake. I moved every spawn fiber into a per pod scope. Yeah, I think that we need to discuss that's when we get to like the actual implementation of like behaviors and things like that. We need to really decide like what the life cycle of each fiber that we're spinning up is going to look like. Um, but I think that's like a later problem. I want to focus more on making sure that rebalancing works, assigning registering pods works, unregistering pods works, and then we can talk like then we can start getting into the weeds about like how the life cycle of the fibers that we're spinning up to do those things should be tracked. Um, but anyways, last piece of the puzzle here on the shard manager interface to the pod health API. So the cluster can notify, or the shard manager can notify the rest of the cluster about unhealthy pods. And it can also check all the health of all the pods in the cluster. Uh, so yeah, I think uh, one of the just talking in general about like how you actually spin up a shard manager. One of the things that I did is I moved, like when you actually create a shard manager layer, I moved the config into just like a parameter that you pass to the layer as opposed to a separate layer that you have to specify. Um, I'm not sure if it's going to make 100% sense to do it that way, but at the moment it felt pretty ergonomic, and we'll see like what I mean by that when we look at the tests, um, or the simulation tests that I set up. Um, But yeah, I think maybe one other interesting piece to talk about with the shard manager is the actual shard manager state object. So how the shard manager keeps track of both registered pods and shard assignments. So in the shard manager, we have this state object, um, and this represents the state of the shard manager at a given point in time. So the state maintains two maps. One is the mapping between a pod address and a pod. And the pod in that case is enhanced with a tiny bit of metadata, just basically when that pod was actually registered with the cluster, like the timestamp that the pod was actually registered. And then the shards, so this is the pods map down here. And then the shards map stores the mapping between shard IDs and the pods they're assigned to. Like I mentioned before, you can actually access this as a hash map external to the shard manager, or from the interface of the shard manager, I should say. And I think there are some additional methods I might add to the interface here, like getting all the pods and everything like that from the shard manager. But for the moment, this is what the shard manager state looks like. The first iteration I went through of this, I actually had maintained the pod and shard mappings as a hash map. So I had pods sitting here as like a hash map of pod address with metadata. And similarly with the shards, I had this as a shard ID option pod address. But I don't know. It just in the tests, because we were creating so many new like because hash map is immutable and we were creating so many like new hash maps every time we were doing an operation like filtering a hash map or reducing over a hash map or grouping up a hash map or something like that, the even in the tests I started to notice like a certain operations were running slowly. So I actually converted the state over to just a plain JavaScript map for now, and essentially the pods map is the string representation of a pod address. So for those of you familiar with schema, essentially I can actually just look at. Hang on, we can actually just look at what I mean in the pod address. So the pod address data type is just the host and port for that particular pod. And I added some methods here just to perform synchronous encoding and decoding of the pod address. So basically, we just get a JSON representation as the keys to this map. So over here, instead of having like a pod address as the key, instead we end up with like the JSON representation of that. So you get like a host, whatever it is, and then the port as the keys, and this is a string. And I've started working on moving the tests to like adapt to this pattern because I just finished converting the shard manager in this like um, in this commit I'm working on to use uh, like this new state. And I started working on converting the tests over to using this new state, and I've already noticed like a small, or it's not really small, it was a relatively significant speed up of like one of the tests that I noticed was already running slowly. Um,
Quick question: the
yeah,
second map that you have there, it's indexed on shard ID.
yeah, shard
Shard
ID is
ID is
just
an object, or oh no,
just a
okay,
branch.
it's just a
That's
branded string. That's fine.
Yeah. So I figured where I could, I would keep it indexed like by the actual data type. Um, so, um, but anyways, the state is kind of interesting, so I thought it would be worthwhile to like just look at it for a minute. Um, so if we ignore the two constructors that I've set up, one of the interesting operations you can do on the shard manager state is group up the shards by their address, which is kind of interesting. So like basically taking if you know the mapping that the state stores is a shard ID to an optional pod address. But what if we want to get something like a pod address to a set of shards, right? So like basically like
The
this
reverse.
operation actually, yeah, basically it does come in quite handy, being able to get all the shards assigned to a particular pod. Um, and so I'm not gonna like go through this code like line by line, but it is kind of like an interesting operation that we can perform um, to get the mapping between pods and the shards that are assigned to them. Uh, what else? So pods themselves, something else that's interesting is pods have a version, which in Shardcake is like a semver string, but it doesn't really need to be. It can just be like a monotonic integer. Like for now, I just made it like an integer. We can always make it a semver string if we want to, but it's really just used as a hint to the cluster um, to signal when the cluster might be getting upgraded, so that like when the cluster is performing a rebalance, it'll essentially skip pods that don't have the max version assigned to them, so that like you don't
Most
end up.
importantly, I'm not sure that there's any advantage in having a semver string here because you don't want to do compat checking. Like even if I
Right.
patch update the cluster, I still want to move the whole cluster to the new version. So rebalancing should pick up the new one. So it's
exactly.
like a strict check. But I
This was
think an
actually
integer is fine.
this was actually Mattia's idea. I have to give him credit. Just making this like an integer, because I think in Mattia's iteration there was like it did support semver, but like in speaking with him, we were both like this could just be like an integer, and it would serve the same purpose and make the code a lot simpler. So I ended up doing that for this iteration, and it's is it does make things pretty nice. Um, and again, like the pod version is just a hint during rebalancing to basically skip pods that might be in the middle of being upgraded. What else is interesting? Semver because Shardcake did, but no, yeah, exactly. Just a hint for rebalancing. So maybe it'd be worthwhile to go through the code for uh, rebalancing the shard manager. Rebalance. So the state of the shard manager, which is just that state object I showed you folks before, is stored in a synchronized ref because there are times where we want to make sure that we atomically access the state to perform an update. So, for example, we'll sort of see it in a little bit, but there's a method in the shard manager that updates shard assignments. So basically, it takes in a set of shards and a pod address, and we want to perform the we want to perform the act of like registering those shards with that address in an atomic manner. So updating those shard assignments to that new pod address happens like without any other like fibers or anything being able to simultaneously manipulate the shard manager state. Um,
But quick question: mm, all of the work that I see here is completely synchronous.
in this case, it is synchronous.
So an
In
update here would be fine.
in shard cake, I think that there is somewhere in here where we use the well, we use update effect here just to make it easier to return an error, but uh, when like if you get an option of none here in shard cake, it is not. It is asynchronous inside the rebalance. Are you sure? I need to look. Let's take a look. Update. It's state. The work done inside updating the shard state is synchronous. Like this in Shardcake, they basically do the same operation. They check if the pods within the state have this particular address, and if this pod is not registered with the cluster, they return an error. Otherwise, they map over the shards and update the assignments. So it is synchronous there. I think the reason they use update, in their case, update zero, in our case, update effect, is basically to be able to return an error. Um,
Matthias is saying that it is asynchronous because it calls the pod's API.
it's not asynchronous inside the update. Like it is asynchronous. They they call the pod API to unassign like shards or assign shards, and then they update the shard state after that.
Because there's a clear, like, if all the updates are completely synchronous, then we should not use a synchronous ref. because that has a cost. And if there's no interleaving, like in the issue is, let me go back. In Scala, where this is coming from in Vue, uh, you might have concurrent updates that happen in parallel. In
Right.
JavaScript, that's not possible. There's nothing that can be interleaved between a closure call. So if all the update is synchronous, then a ref is completely fine. The only case we would need a synchronized ref is if the update itself is effectful. Returning an error here, I'm not sure it's justified. Could quite literally like don't update and either throw an exception or do something similar on the update interface.
Yeah, I
But I
mean
think
that we.
we can start in this way and eventually optimize it.
I think that what Mattia is referring to, by the way, is so register pod. Whoops, sorry. Pods. So here's one situation where we call the pods API and then we update the shards after calling the pods API, and then there's another situation, basically the same thing. Instead of unassigning shards, we do the same thing when we assigning shards, and then we perform the updating the assignments inside the like shard manager. So I think the asynchronous call happens before we update the shard manager state. Like calling the pods API doesn't happen as part of the updating of the shard manager state. That makes
I
sense.
mean, synchronized ref would be acceptable if that call is part uh, of the atomic operation. But if
Right.
that call is not part of the atomic operation, then a ref is slightly more performant. Doesn't it's not a huge deal, but there is basically a semaphore which is taken and released. So
Right.
there's like 4 or 5 ops versus literally just an atomic update. But anyway, those are like next iteration cycle, I guess.
Yeah, I mean, I think that we basically just need to make sure that there's nowhere that we actually do a concurrent, uh, like an asynchronous call inside an update. I don't think there is, but I kept it as a synchronized ref because, kind of like you said, didn't seem like the right time to make that optimization. um, but anyways, maybe I don't know like what you think the best use of time would be, but I thought it'd be maybe interesting to go through like first, like maybe we can talk about like how the shard manager is initialized currently, and then we can go through some of the ops that it can perform. Or
I think we could also have a look at the test suite,
sure,
kind of um, understand the use cases very well. Again, for the folks that are just connecting now, the shard manager in the cluster is supposed to be a single instance, and the responsibility of the shard manager is to allocate shards to pods. A pod is basically a JavaScript process. We're using Kubernetes like names, but pods are JavaScript processes, and you can have a cluster of them. How entities are executed on pods, the mapping for efficiency reasons, we loop through shards. So basically, we have a fixed number of shards in a cluster. They are configurable. They can be 64,000 or whatever number, and each entity is hashed. And based on the hash, we assign it to a shard. That operation is static, and that can happen. Basically, the client can know directly which shard to communicate to. The mapping between a shard and a pod is what the shard manager is controlling. So you have a single entity within the cluster that is responsible for this allocation. And the logic is very nice because it is a single process, and one may think, okay, it's a single process and it impacts availability on the cluster. You have a single point of failure. Well, in reality, even if the shard manager goes down, given that the shard allocations are fixed, as long as you don't have pods that go down while the shard manager is down, everything is operational. So this makes it highly available, even in the circumstance of the shard manager going down. And having a single process for the shard manager makes the assignments much easier, and we basically don't need a zookeeper or a distributed state management solution or stuff like that. Clearly, at some point, we might want to implement stuff like Raft to make even the shard manager more highly available. But this is the start. So the shard manager is kind of the central piece where all the coordination happens. Everything else is statically allocated, and they can execute independently. It's kind of the trickiest part of the system to some extent. So that's why I was curious on the test suite.
Yeah, no, we can take a look at some of the tests I've written so far. Um, so shard manager is the only writer who changes the network topology of entities. Yeah, yeah. Um, pods can also be registered by the shard manager, right? I don't know if you mentioned that. I think you focused mostly on the shard assignments, but the other thing that only the shard manager is capable of registering new pods, which makes sense, as you kind of like pointed out, with the cluster.
Kind of
But
the keeper of the cluster.
exactly. Um, Mattia, I haven't encountered a use case for this registered at thingy yet. Maybe like you can comment on like if you know what the metadata that's attached to pods is useful for. Um, but yeah, I just kind of wanted to know if there's a use case for registered at that I haven't come across yet. But anyways, in the test suite right now, we have 3 pods that we kind of statically define up at the top. Each one of these has a different host and port, but they all have the same version. And at the moment, so there's 2 like groups of tests in this test suite. One tests specifically like rebalancing, and one is kind of a simulation test suite where we actually have more of like kind of round trips happening through the shard manager. Um, so at the moment, since I've reworked the tests for the new state, I haven't gone through the simulation tests yet. I've only gone through the rebalance test suite. But we can take a look at this. So this first test here takes a look at specifically does the shard manager rebalance unbalanced assignments. So right now we set up 2 maps where we have essentially pod 1 and pod 2 registered with the shard manager. And then we have 2 shards that we create, both of which we register with pod 1. And clearly this is an unbalanced cluster because we have 1 pod with 2 shards and 1 pod with no shards. So we can create our state here and then call one of the methods inside shard manager, which I'll pull up, but we don't have to necessarily go through. Oops, hang on a minute. Shard manager. So let's take a look to side. These 2 methods in here basically figure out the assignments and unassignments that have to happen for a particular pod. So we essentially get 2 maps back where we have a mapping of pod addresses to the shards that have to be assigned to that pod, and similarly the unassignments for a particular pod. And we have 2 methods in here that essentially are called in 2 different situations. One is when we have pods with unassigned shards. One is for when we have like pods with unbalanced shards. but the semantics of when that gets called, when each one gets called, we can look at in a second. Um, but in this case, we have register at was planned just for metrics, estimated the average pod life since register. Okay, very cool.
That's a use case.
Yeah, that is a good use case. And actually, there have been like metrics added since to Shard Cake, and I've started to incorporate them into the Shard Manager as well. There's actually like Shard Manager specific metrics, and then there's also metrics for like the pods themselves. Um, but anyways, getting back to this test, so we have two pods, one with two shards, one with no shards. So when we try to decide the assignments, we should end up with essentially the cluster deciding to create an assignment of one of the shards to the second pod, which had no shards previously, and then pod one should be getting an unassignment of a shard. So essentially moving one shard from one pod to the other in this particular case. And I can actually just run test. So at the moment, we have in the rebalancing test suite, everything is working currently. And this test down here is the one I was referencing at the beginning when we were talking about why I swapped to kind of a vanilla JavaScript map from our hash map. That test I think was taking somewhere around like 4 seconds or so because we were doing a lot of like um, copying and recreating hash maps and things like that. We still do a lot of copying and recreating maps in this test, which is why it takes like 600 millis, but it's definitely a lot quicker now. Um,
I mean, to an extent, we should probably also understand why it's kind of slow in the hash map, because the hash map is a persistent data structure. So you don't copy it, you modify parts of the tree, which should not be a lot slower. I'm curious if we can maybe benchmark where the issues are coming from. Team is
yeah,
usually a good
Tim,
hardener of performance.
Tim, if you're watching this later, yeah,
Please.
please help us with HashMap. Um, so the first test here is kind of simple. We're just testing that if the cluster is unbalanced, it should rebalance itself. Um, in the second test here, we're basically testing that if we have a pod in the cluster and the cluster is unbalanced, but the pod has an older version, excuse me, that we don't rebalance to this pod, basically. Because we never want to send shards to a pod that's running an older version, because obviously it's running an older version of stuff and we're probably in the middle of like a cluster update or something like that. So very similar to the first test, we set up our like two um, states here, and we're basically testing that both the unassignments and assignments that we get back from deciding how to rebalance should both be empty. Milad? No. State.make is just a static constructor I put on the custom shard manager state object. We could also originally I had the constructor for state as a private constructor, but I ended up needing the vanilla constructor anyways. So make could literally just be new state instead of state.make. It's it's doing the same thing right now. So I should probably actually remove make. um, because it's doing the same thing as the vanilla constructor at the moment. Um, if and then we have a third test here, which is basically testing that if the cluster's already balanced, we shouldn't rebalance the cluster. So similarly, in this case, we've got two pods, but we've got a shard on each pod. So when we decide how to rebalance, we shouldn't get any new assignments or unassignments. Um, this is kind of like an optimization that we do inside rebalancing. which is basically like we have two pods, right? And we have three shards. So in this case, like it wouldn't make sense to ping pong a shard between these pods every time we rebalance, right? This doesn't make any sense to do that. It would be like an unnecessary operation.
It's like
Um,
it's unbalanced, but not too much unbalanced to justify a resharding.
exactly. So in this case, like we're basically testing that when we have one pod with two shards and with one pod with two shards, one pod with one shard, that we don't constantly send one of the shards between those pods. Like that's an unnecessary rebalance.
I guess this
Um,
is regardless of the cluster size. You could have four pods, three with one, one with two, and you have the same situation.
exactly. So then we actually do the exact thing that you said. If there's a more than one shard difference, we test that we actually do rebalance in this situation where we have two pods, but we have three shards assigned to one pod and one shard assigned to the fourth pod. So this is very similar to like the first test that we set up, but it's basically like a sanity check to make sure that like when we have many shards assigned to one pod that we do rebalance when there's more than a one shard difference. And yes, Mattia, we could set a threshold. Um, so I think um, I think at the moment there's actual specific logic. I forget where it is. I think it's in pick new pods for this. It is in here somewhere. If the new pod has one less, as many or more shards than the old pod, don't do anything. Like, this is essentially the place where we currently do this. So if there's a one shard difference, I don't think we currently do anything. Well, we don't currently do anything. But if there's more than a one shard difference, we do something. We could. Isn't there a config? I don't remember. Let me look. Port, number of shards, rebalance interval, rebalance retry interval, rebalance rate. No. At the moment, it's literally just a static check. Like a one shard difference doesn't trigger rebalancing. Um, anyways, moving on. In this test, we are making sure that we're picking the pod with less shards. We could actually probably make this test more robust. But right now, basically, we have three pods in the cluster. We have two pods assigned to pod one, and we have one pod assigned to pod two. And we're basically making sure that we're sending one shard to the third pod, which currently has none, and taking a shard away from pod one, which currently has two, so that we end up with a perfectly balanced cluster. Um, and then kind of a sanity check. Shouldn't rebalance if there are no pods, right? So,
Yeah,
and
finally rebalance.
indeed. This test is kind of the more intensive one, where we're basically testing that the cluster should balance well when we have many nodes that are starting in sequence. So the logic might be a tiny bit hard to follow, but basically we start out with a state here where we have no pods registered with the cluster, and we have 300 shards in the cluster. So we basically have no pods, 300 shards, right? Um, oops. Um, and here we're basically creating a 30 pods. We're spinning up 30 pods and we're reducing over the original state. We create an address for the pod, we create the pod with metadata, and then, how do I keep doing that? We create the new shards and new pods for the next state that we're going to create. We add this address to, like, we basically add this pod to the state of the cluster. Um, again, stop me if something doesn't make sense. Um, sorry, we add this pod to the state of the cluster, and then now that we have that pod like added to the cluster, we basically do the work of deciding if we need to make an assignment or unassignments from the cluster. And this is the logic I believe that's in the actual shard manager, to decide like when we have to call which method. Um, I think that we also check if we're doing the assignments immediately or not. Um, but basically, this was actually a bug in the shard cake tests that I found, that I'm actually going to contact Pierre about at some point. Right now, their tests will always pass for this because they're always calling, I think it's the unbalanced shards method, or maybe it was the other one. But basically, like they always end up with like an empty state. But because it's like eventually you end up with the way that they're doing their assertion, you end up with an option. Like it's always going to be true. So I actually have to get in touch with Pierre and let him know. Um, anyways, so as we're spinning up pods, we figure out if we need to make any assignments. And if we don't, we update the shards in the state. Right. So we basically go through and unassign any shards that need to be unassigned. We assign any shards that need to be assigned, and then we return a new state. So as we reduce over these 30 pods that we're spinning up, we're basically making sure that we end up with a balanced cluster at the end. So at the very end here, we take the result after reducing over all the pods. We could calculate how many shards are assigned to each pod. We make sure that we have 30 pods in the cluster, and then we make sure that every pod should have a size of 10. Because with a perfectly balanced cluster, 300 shards to 30 pods, every pod should have 10 shards. That gives us 300 total shards.
Uh, Apologies, just a quick question. Those tests just test the assignment functions. So basically, the decisions that the shard manager is going to take.
Yep.
Uh, that's not though the actual process that goes on in the shard manager upon allocating or deallocating shards. Because
No.
when we deallocate a shard from a pod, we need to wait for confirmation that the pod actually
Hmm.
deassigned the shard. Otherwise, we risk ending up with two pods that think they have shard assigned.
Yeah, this is basically testing all of the synchronous rebalancing work because it's still like a complex algorithm. So we want to make sure that we're like actually doing
Got it.
everything properly. But I started to write.
And I guess at the end, you just compare previous state with wanted state, and you then call the pods
Mhm.
APIs to get uh, to the new version.
Yeah, I mean, if we look at in the actual implementation here, if we actually look at um, uh, the register or um, the actual rebalance, if we actually went through the whole rebalance algorithm, um, there's quite a bit of stuff that's being done. The first thing that's done is basically what we do inside the tests, except we also check if we need to do it immediately or not. Because if we don't, then we can obviously do the rebalancing according to the rate. Otherwise, we need to do it immediately. But there's like a whole bunch of other logic in here where we test. We first ping the pods. We test if the pods are actually available. We remove any pods that are not healthy. Like there's a whole bunch of work that goes on inside the rebalancing algorithm. But the tests that we just ran through is literally just the synchronous work for rebalancing. But to your point, Mike, there are some simulation tests I started working on, which currently I'm skipping because I don't know if they're going to work because I changed the way the state looks. But here we do some actual like simulation tests where um, we basically like go through the full like rebalancing, registering pods, etc. Um, So we can look at some of this, and there's a lot missing from these simulation tests. I think I've only written like 3 so far, but there's like a ton of like stuff that's uncovered currently because I literally just started doing this.
Yeah, I mean, of
um,
course, it's
but
it's
uh,
one of those things that I guess needs to be well tested.
indeed, this needs to be extremely well tested. Um,
And to be
so
clear, one of the guarantees that cluster has is that you're gonna have only one instance of your entity behavior running at any point in time, and this is fundamental for actor systems because it's what allows you to basically use single writer principles, which means you don't really have to care about locking, and it's what allows for insanely good performances at scale. You can have millions of actors, uh, each actor does independent things, and they don't need to coordinate between each other. They don't need to basically you never need to lock stuff, and that's only possible because you have the guarantee that only one instance of your process is running within the cluster, and this is guaranteed by having basically an entity linked to a shard. So one entity points to one shard. One shard can have many entities, but one entity will only ever live within one shard, and one shard will only ever be allocated to one pod, never allocated to two pods. Because if a shard gets allocated to two pods, then you lose the guarantee of the single writer principle on the entity. So all of this work is really the heart of the cluster, which is why I'm saying this. It has to be tested, like it has to be 100% coverage at a minimum.
yeah, now there is a lot of work to do on the tests, but I think like there's already a good coverage for at least like the synchronous part of rebalancing, like when we need to figure out do we need to assign or unassign shards to a particular pod. I think we already have like a pretty good coverage for that. But there's a ton of work that needs to be done for simulating the actual shard manager. But I have started some of it. So when you actually construct a shard manager, the layer that provides a shard manager, you can provide the config um, like dynamically inside the layer constructor. So you can like, specify which port you want the shard manager running, or maybe you want to change, I don't know, how often the pod is pinged. I don't know. Um, but for now, we just leave it with the defaults. this, is, this is good. Thanks, Dylan.
Dylan,
Um,
pay attention.
um, so, anyways, a lot of the other layers that the shard manager depends on right now in the current simulation tests are just no op layers. So they either always like return true or always return healthy or return empty maps from storage or whatever. In a true like fully like whatever test suite, we'd have tests that really like incorporate all of these different things. Um, but for now, I just have a few simple simulation tests set up that are basically the same ones I think that Shardcake has, with a few things changed. Um, so the shard manager itself depends on a couple of things. So it depends on having access to cluster storage, obviously. It also depends on a pod health API, which is external to the shard manager. So um, you can basically provide different implementations to check like whether or not a pod is healthy. Um, so if you're running in K8s, maybe you'd have like a K8s pod health API, or if you're running locally with multiple different processes, maybe you'd have like a process manager that's checking if pods are healthy or whatever. And then the actual pods API needs to be provided as well. So the thing that actually communicates with the individual pods. So these three things are required by the shard manager in order to be able to function. And we, in the tests, currently provide a local pod health API or a local pod health layer, a no-op layer for pods, and a no-op layer for storage. And then this test live layer is used in most of the tests, except for the last one, which we'll take a look at in a second. But maybe we can look quickly at this like simulate function. So this simulate function basically takes in a read-only array of simulation events. So basically things that we want to trigger some behavior in the cluster. So it's again, this is like for testing purposes to make some things easier. But basically, the simulation events that we have available to us are either currently we can register a pod or unregister a pod. And that's because at the moment, the only two things that require simulation events that I've written, um, yes, in the for sure, Mattia, in the simulation tests. Like there are so many tests that need to be added to the simulation stuff. It's there's a lot. At the moment, my simulation tests are just testing scale up and scale down, um, and then persisting state to storage. But um, so we have two simulation events here. When we register a pod, we basically just call manager.register. And then similarly, when we unregister a pod, we're just calling unregister on the shard manager. And simulate basically just iterates over these events, handles them, and that's really it. So again, these tests haven't been touched yet since I updated the state. So we could run them and see if they work, but um,
I
we
guess
can
it's
go.
a good test to see
Yeah. Let's just
if the
run them and see
changes
if.
were, or it's a good way to fail live.
Oh no. Yep. Kind of what I was expecting, but um, let's talk about the tests first, and then maybe we can like look into why some of these things are failing. Um, so in the first test here, we're basically setting up 20 pods. We're setting up like 20 pods and then registering them all. This register pod method is just defined down here. It's a helper to just uh, construct a pod and then create the simulation event for registering the pod. Um, and we wait 10 minutes because with the test clock, we wait 10 minutes because we um, we're not rebalancing immediately, so we want to basically wait for the cluster to settle. And then in an ideal world, if everything wasn't failing since I updated the tests, we would grab the assignments from the manager, so all of the shard assignments here, and we would end up with um, essentially 12 shards per pod because the default number at the moment, this can be changed. The default number of shards that we spin up is 300. Um, I know Mike and I have we've talked about like making this number much larger. For now, it's 300. We can always change it, but
I mean, for
um,
testing purposes, it doesn't really matter. The only thing that would matter is checking that the performance doesn't like go to zero if that number grows. But the point of having more shards than we currently have is because resharding a cluster is a very tedious operation. So, given we persist all the messages and so on and so forth, resharding the cluster means quite literally rewriting the whole event history, or at least changing some fields in the whole event history, which could be a fairly intensive operation. And
And we should probably
the rule of thumb,
define for the audience, Mike. You might want to just clarify the difference between rebalancing and resharding.
yes, absolutely. So rebalancing is the operation of changing the allocation between shards and pods. So if the topology of the cluster changes, which means you're adding new nodes or you're removing nodes, then you're rebalancing the same shards onto a different topology of pods. Resharding a cluster means change the physical number of shards. When would that be necessary? Let's say you, for example, start with, I don't know, 16 shards. You think, okay, 16 shards, probably start a cluster with single node or like 3 nodes. You have enough shards to be well distributed. But then at some point in time, your company grows and you find yourself with a cluster that has 32 nodes. But if you have 16 shards, only 16 nodes at the maximum are alive. And given that entities are distributed by hashing the entity identifier and assigning a shard to that, if you only have a few shards, you might end up with a single shard has many that has many entities allocated, while another shard doesn't have that many. It's kind of like a hash map with just a few buckets. You want the number of buckets to be enough to cover potentially the whole lifetime of your cluster. And if you have a number like 1024 or 2048 shards, that's enough for 3 nodes, that's enough for 100 nodes, that's enough for 300 nodes. So at the end of the day, we should probably make the default something like 2048 or even a bit larger, uh, to to basically guarantee that you never end up actually having to reshard. Uh, that's and to be honest, even making it a configuration is kind of, it's one of the configurations that you're not supposed to touch that much. Uh, you're only supposed to touch it if you realize you have quite literally some issues that that requires you to change it. Apologies, Mattia is saying something. I'll put it on the screen. Also, resharding is usually an operation that one does when data scales up quickly, quick user growth. So should be performed with the smallest time of the cluster being down possible. Yes, and it is kind of hard to do uh, in that situation, which is why the best way to do resharding is not to reshard at all, is to start with a cluster that already has shards. It's similar to folks that know, for example, how Kafka works. You have a topic, and a topic has partitions. You want your topics to start with the right number of partitions, because repartitioning a topic requires the cluster to be down for a period of time.
Yeah.
Best way to solve a problem, always not having it. Yes, indeed. That's
Nice.
exactly what what I meant.
Yeah. Um, so there, I'm trying to figure out what I did to break my simulation tests. It's definitely something to do with the changes I made to state, but we can at least walk through the test, and I can show you folks like what we're trying to test here. Um, but as I mentioned, we simulate setting up 20 pods, so registering 20 pods, wait for the cluster to settle, and then the idea is that with the default number currently at 300 shards, if we set up 20 pods, we want every pod to have 15 shards. We want every pod to be assigned to the cluster. This should probably just be registered. Um, or all pods like have assignments maybe. But the idea is like we want all 20 of these pods to have assignments, and we want all of them to have 15 shards, um, because they've been like successfully like rebalanced, um, to have that many. And then to test like scaling up, we then simulate adding another 5 pods to the cluster. We wait 20 seconds, which is not enough time based on the default rebalance rate to fully like rebalance the cluster, but it should start rebalancing the cluster. So we basically test that each of the new pods receives 6 shards, um, which is what we should have with the default rebalance rate. Um, and then if we wait the rest of the time for the cluster to settle, and we grab the assignments a third time, then we should have 25 pods, each with 12 shards. Um, Probably gonna have to go through the like shard manager and figure out like where I broke this. But that's what I get for changing the entire way that state works in the shard manager before we streamed. Um, if I reverted this back to the hash map implementation, you folks could see it passing. Um, but
By the way, uh, please can you branch off a new branch where you stop the changes at the point where the test takes too much? Because I'd like to
yeah,
check after our call at a different point in time, why is it actually taking long? Because it
yeah,
might be that we are just hashing in a wrong way, or there may be changes that makes it faster even without changing the data structures. It would be helpful anyway
no,
to
that's in an ideal
test out those structures well.
I was gonna say because in an ideal world, using hash map and hash set would be nice because they just have the operations already on them that we want to use. But yes, I can do that. I'll make a copy of my branch, uh, because the last commit in GitHub currently is uh, where I had everything working with hash map and hash set. Um, so the other
And for
simulation test,
Tim that is gonna watch this stream later, he knows what's the target to optimize.
exactly. Um, The other simulation tests I have in here are the inverse of the first one. So instead of scaling up, we start with 25 pods and then test scaling down. Basically the exact same like a logic in reverse. And then the third test that I set up here is essentially a test that looks at, do we successfully persist the shard manager state to the cluster storage if the shard manager gets restarted. So um, essentially like when we restart the shard manager, one of the things that it should do on shutdown is persist everything to cluster storage if it's shutting down obviously like cleanly. So if we look at here at finalizer, um, it persists its shard
That's to
assignments.
avoid just to start in a different state, basically.
Exactly. So that when we restart the shard manager, it rehydrates from cluster storage. Because basically, like as part of shard manager initialization, it reads from cluster storage, pulls down all of the current shard assignments and pod assignments that it knows about, and hydrates the state with those things. Then similarly, we add a finalizer here so that if we shut down the shard manager, it should persist those things to cluster storage. Uh, Yeah. So, um, what we're testing here is basically that. Like, we set up a shard manager, then we let it run and shut down. So we run the setup uh, simulation, and then this is the test simulation where we grab the same storage, which we're providing to the wrapping test, which stores everything in memory, and just makes sure that um, that these things are that essentially the storage has stuff in it. Like we're making sure that we should have, and making this test more robust would just involve like making sure that the correct pods and shard assignments are present. For now, I just was checking that there was actually something we were getting back from cluster storage. Um, but yeah, there's a ton of work to
And
do.
maybe at some point we should even evaluate if um, like if all the state should actually be always persisted, because the shard manager is kind of event sourced in a way. It basically takes the decisions as a sequence of events. We could quite literally always store the events before even starting the processing. So when it starts back, it can always get to the previous state. That could be an optimization. We lose a little bit of time in like don't take the decisions immediately, but what we gain is we are sure that the state is always consistent, which is
Yeah,
similar to what we do with persistence of the messages in the entities. We're
yeah,
not trying to get maximum speed. We're trying to get maximum consistency, basically.
yeah, maximum reliability. Yeah, I mean, we can. I think that makes a lot of sense. Um, but there's definitely a lot of like simulation tests that need to be added because we're basically testing nothing related to like the interaction of these components aside from with storage. Um, but that way raft would be
Yes.
easier with an event, like with an event source log or with an event log.
No, well, with Rock, you basically never lose the state because you have a cluster of shard managers. So one shard manager can go down while the other twos are up. But on the other side, it has other drawbacks. And apologies. The other message was also if log gets too long, one could also use one snapshot event. Of course, like any event sourcing, you persist a recent enough snapshot and you persist the list of events that every 25 event, every 100 event, you persist the whole state and rehydrate the rehydrate the state plus replay the last X events. That's one way of doing it. But
Oh,
anyway, all of this is further down the line. At the moment, we don't really care if we lose the state upon restart, because losing the state of the shard manager doesn't mean damaging the cluster. It just means that the new shard allocations may look differently from the previous ones, and you have a rebalance, which is only due to the shard manager being restarted. So it's
yeah,
not.
because the pods actually are disconnected from like the shard manager can force a rebalance, but the pods are actually reading their assignments directly from cluster storage. They're not necessarily getting it directly from the shard manager, if that makes sense. That's why like the when a pod starts up, it's getting all of its assignments initially from cluster storage. Then at that point, like I think the shard manager is like we can actually look here. So it's
Well, I mean, they have
API.
to be in sync.
Right. But I'm saying, like, let's say the shard manager goes down, right? Like the pods, when the pod is hydrated, it's always going to be hydrated with the state from cluster storage. And then if the pod gets assigned or unassigned shards, like, yes, the shard manager does that. But to your point, like much earlier, if a shard manager goes down, the cluster can still be operational because the pods will have the cached assignments from the most, yeah, in sync shared storage. The pods always have that cached like shard assignments from whatever the last time they communicated with the shard manager was, or they read directly from cluster storage if they, you know. but yeah, I think like one of the awkward things right now with converting, like I'll talk about like that. Yes, we got a maybe a tiny bit of performance with using a vanilla JavaScript map. So obviously, if there's perf work to be done on hash star data types in effect, but um,
We hear the hash star algorithms. I wrote the algorithm, so I'm not a performance expert. I probably fucked up every single thing that I could have.
but Tim is
They
very smart.
work. They work, but yeah, pun intended.
um, the only awkward thing that like comes up with switching to like a map and set, like vanilla map and set based API, is the like having to convert back and forth between like the stringified representation of pod address as opposed to just like being able to use it directly as a key, and then also the APIs that the service APIs that are not in the shard manager that expect a pod address or a hash set or a hash map or whatever, like communicating with the pods APIs, for example, those expect a hash map or a hash set to be passed in. So it's like there's a lot of like converting back and forth that has to happen in certain places, and that's like the only awkward thing at the moment. Um,
Yeah, I mean, I think at the end of the day, either we end up um, with the hash maps and hash sets, or if for whatever reason we can't get to an acceptable level of performance for this specific case, because at the end of the day those are small structures. You're basically storing either shards to pods, or and like, yeah, fixed sized structures. They're not like hash maps are really good when you might have a million entries, and of course you don't want to copy a million entries upon every change. But if you have 2,000, 3,000 elements in a map, copying it won't be a big deal when you make a change, because most of the time you read, just a few times you actually end up changing state. And when you change state, you can make a full copy and then mutate the thing. So that's where you might gain a little bit of performance. Now, if we can't use the hash map slash hash set structures, we can also think about two structures that are called index map and index set. So an index map would basically have a backing map and would be a map of string to a tuple of the key plus the value, and an interface where you actually always uh, interact with the actual key. So the indexing is done internally to the structure. The API doesn't even see it.
right.
I haven't added those because my hope was that we could get away with hash maps and hash sets, and but those structures exist. It's not rocket science. I could quite literally hack a morning and have those in the core for the cases where we need those. Because there are other places, for example, in core where we initially used hash maps and then we switched to maps precisely for this reason, because lookup was
Yeah,
way faster.
I think it's worth like doing a perf pass or on the hash map and hash set, or really just hash map because I think hash set is based on hash map. But um, I think it's worth doing a perf pass on it. But yeah, I mean it. I think either approach is fine. It's just whatever is going to make, because the logic in here starts to get pretty complex, and so the less number of times you have to like convert something back and forth, the better. Um, but
Good.
anyways, yeah, that is what I wanted to cover today. I thought it would be an interesting discussion. I want to get my next steps are basically to get like the simulation tests working again, And once the simulation tests are working again, I'll probably add some more like tests, um, like simulation tests that look into like how other services are actually interacting with the shard manager, make sure that like the interplay between like the pods api and the shard manager, pods health, everything is working the way that we expect. And then I'll probably like the next time that we chat, maybe um, we can start looking again at the actual entities and like what's going on the pods themselves. um, Once the shard manager is in a place that we can actually use it. So
Good.
yeah.
That's
um,
not too far, considering
yeah,
that
no,
this is quite literally the most complex piece.
yeah, I'm pretty happy that we're already where we are. So yeah, I hope everybody found our discussion today interesting. And hopefully we'll be able to get back on a regular schedule.
Indeed. And I guess we'll keep streaming also on Twitter/X, because apparently we have 450 people concurrently watching this. So, hi
Well,
everyone, and
hey
see you
everybody,
next time. Thank you
take
for watching.
take care, everybody.
Take care, folks.